worker nodes, we already installed containerd, kubeadm, kubelet, and kubectl on both worker nodes. Also, if you didn't already execute it, run sudo swap off-a command on both worker nodes to disable swap as described in the prerequisites. So once all of this is installed and configured, we can now actually join the worker nodes to the cluster, which is actually pretty easy. Remember that we got an output after kubeadm init command with join subcommand, which looked like this: kubeadm join and then some parameters. That's the command with a generated token that you can execute on a worker node to join it to the cluster. So this command basically includes the address of API server, because the worker node needs to know which cluster it is connecting to or joining to, as well as an automatically generated secret token so that control plane components can identify the worker and basically let it join the cluster. However, if you don't have that command anymore, don't worry, we can print out this command anytime we need to join a new node to the cluster. So let's see how it works. Now the token gets generated on the master, so we need to create a new token and print out the join command on the master so that we can copy it and execute on workers later. So going back to the master node, we're going to use kubeadm to do that. Now I want to give you a pro tip here, which is going to help you a lot when working with either kubeadm command line tool or kubectl tool. Now both of these tools, just like any other command line tool, also have a help option, which shows you pretty nicely all the subcommands you have with them. This is the init command that we executed with kubeadm, and some other subcommands with the descriptions, as well as possible options you can pass to those subcommands. And one of the commands you see here is token, which is a subcommand to manage the secret tokens that we need to connect worker nodes to the cluster. So I'm going to do kubeadm token, and I'm going to do --help again to see the subcommands of kubeadm token command itself. And let's do that. And right here you see with kubeadm token, we can create new tokens, we can list existing tokens, and so on. Again, we want to generate a new token for the worker nodes. So I'm going to do kubeadm token create and do --help again to see what other options I can pass onto it. And execute, going back here, usage, kubeadm token create. And one option that I have here, one flag, is print join command. So in the description, you see that instead of just printing out the newly generated token, this option will actually print us the entire kubeadm join command that we can simply copy and execute on worker nodes. So I'm gonna copy that option, add it at the end, and let's execute. And there you go. This is the command we're gonna copy and execute on worker nodes. Again, this is the API server IP address. This is the port where API server is running on this machine, right? We have the newly generated token, and we have the CA certificate hash so that worker node can identify itself with the master node. So that's our command. Let's copy this, go to worker 1. Now this command will actually require sudo privilege. So either you execute it with a root user by switching to root, or we can just do sudo at the beginning. So with sudo, let's execute the command, and you see the kubeadm is executing different phases. We have the pre-flight phase, just like with kubeadm init, and another simple phase that basically configures kubelet, which is already installed and running on worker node. And basically kubeadm will tell then and instruct kubelet what to do. So in the background, worker node just joined the cluster, and any pods that needed to be scheduled on the worker node right here has been scheduled automatically without our involvement. So to check that, let's go back to the master and let's do kubectl get node, and we should see worker1 in a ready status, which is now part of the cluster with the same Kubernetes version. We can also check an extended output with internal IP addresses. So this is the master, this is the worker. And now if we do kubectl get pod in all the namespaces, and again, a wide output or extended output, you see that on the worker node with this internal IP address right here, we have 2 pods that were automatically started on the worker node. The first one is kubeproxy and another one is weavenet. Now, kubeproxy and weavenet are both daemon sets, if you remember, and daemon sets will automatically schedule a pod in each single node in the cluster. So everything seems great here. Let's actually go ahead and execute the same kubeadm join command on worker2. So we don't have to generate a new token for each worker node. We can actually reuse the same one. So I'm going to copy this and execute here as well. And it's done. The worker node should be now joined to the cluster, as well as kubelet was configured and started. Let's actually check the kubelet service status. And we see that it's running in an active state. And again, let's check the nodes. Master, worker1, worker2, which is in the ready state with this IP address. And again, on worker2, we have the same 2 daemon set pods, kubeproxy and weavenet. Here, I'm going to remind you that joining the worker nodes is actually possible because we opened all these ports on master nodes as well as the worker nodes, so that different processes on master and worker can communicate with each other in order to join the worker node to the existing cluster. Now, as you already learned with weavenet, which is a pod networking layer inside Kubernetes, the weavenet pods on all the nodes should now be talking to each other and forming this network group so that we have a pod network in the cluster. And as we see, they are running in the cluster, but we don't know whether they are talking to each other or not. Did they actually discover or find each other, and did they form a group? So let's actually check that as a next step. So I'm going to clear that, and what I'm going to do is I'm going to print only the weavenet pods and their names. So we're just going to do a simple grep, and we're going to do weavenet here. So this will give us the pod names of all the weavenet pods. So I'm just going to take one of them, doesn't matter which one, and I'm going to check the application logs or weavenet application logs in the pod. And to do that, very simply, I'm just going to do kubectl logs, name of the pod, name of the namespace where the pod is running. And let's execute. Now, the logs actually don't belong to a pod, but rather a container that is running inside the pod. And if we have 2 containers running inside the pod, like in this case, then Kubernetes or kubectl doesn't know which container logs you want. So for that, we need to actually specify a container. So again, copy that and specify container weave. This is the first container, this is the second container. We want the main application logs. And execute again, and there you go. And here you see the logs of weavenet from start up till now. And here you see a bunch of error messages that says that it cannot connect to this IP address, which belongs to the master node, on this port where WeaveNet is running. Now let's check the logs of another pod. Let's say this one, for example. And here you see the same exact error messages. Error during connection attempt. So it's trying to connect to WeaveNet pods on other two nodes, one of the worker nodes and the master node, on the port 6783 where WeaveNet is running, but it is failing to do so. So what is the problem here? As I mentioned, the networking plugin gets deployed on every node. So together, these individual networking pods deployed across different nodes make one shared pod network. In our case, this networking application is WeaveNet, which listens on port 6783 on each node. And for them to connect to each other, they need to be able to talk to each other on this port. However, if we check our firewall rules for the nodes, you see that port is not open on the nodes, right? So master node as well as the worker nodes do not allow talking on port 6783. So very simply, we need to open that port so that the WeaveNet pods can talk to each other. So to fix that, let's just open this port on master and both worker nodes. Go to security group, edit inbound rules, and we're gonna add another rule, custom TCP, port 6783. And again, this port should be only open for instances inside the VPC because we don't need any outside or external connection to WeaveNet. So that's gonna be 172.31.0.0.16, which is our VPC CIDR block. Let's save the rule. That's the security group of master nodes. Let's also configure worker node. Security group. Again, add a new rule. 172. Our VPC CIDR block. Save rules, and that's it. This should have actually already solved the problem. So if I go back and print out logs of, again, one of the WeaveNet pods, and another option we have with logs is to stream the logs. So we can see actually output in live is -F. So we're gonna tail the logs. And right here you see connection accepted. So we have a successful connection with a master node, connection edit, as well as with worker 1. So now all the WeaveNet pods should be actually talking to each other. And let's actually check the other WeaveNet pod as well. WeaveNet pod on master node as well as worker 2 are connected to the WeaveNet on worker 1. Once we install the network plugin and check its logs, etc., we want to see the status and make sure that all the network plugin pods have discovered each other and we're able to actually connect to each other. And we can extract this information from the logs. However, we have a way of seeing the status in a clean, nice output using weave command itself. So let's see how that works. First of all, let's output our weave pods, including the IP addresses or the nodes where they're running at, and grep on weave. So we have 3 WeaveNet pods on each node, and let's actually check the WeaveNet of the master and its status. And we're going to do this with this command. Now you will learn what this command means and all these options and all these subcommands, all these options and how it gets executed step by step in the later lectures. At this point, you can just copy and paste the command to check the status. So the only thing you will have to change is the name of the pod. So you'll have to replace it with your own pod name and execute. And this will actually execute a weave command inside the pod and give you a status that will show you some important information, like how many targets it was able to discover and how many connections it was able to establish. So this is the important part here, which shows us that this specific WeaveNet instance was able to find two other peers, these two, and was able to establish connection with them. So if it says 2 failed connections or 1 established and 1 failed, it means the WeaveNet pods were not able to find each other. And probably you don't have 3 peers, but rather 1 or 3. So in this case, everything looks great. If you have any issues and you don't see 2 connections here, you can reference the WeaveNet troubleshooting documentation that will help you fix any of these issues. And this means now that the WeaveNet pods on all the nodes are connected, we can actually schedule pods on the worker nodes. And finally, to test our setup and that everything is working as expected, as a final step, let's actually schedule a test pod in the cluster and see that it's running on one of the worker nodes. And to do that in the fastest way and most efficient way, just to test basically scheduling a pod, we can use kubectl run command, which basically needs pod name as a parameter. So kubectl run, and let's call the pod test and the image name, because the pod needs to run a container which is based on some image. And simply nginx image from the Docker Hub will do. And if I execute this, this will schedule a pod called test with nginx image in a default namespace. Let's execute kubectl get pod in a default namespace again. You see the container is creating. Let's add a watch option, and there you go. Test is running. Just to make sure that it is running on one of the worker nodes, let's actually do an extended output with -o wide, and there you go. As you see, it is running on worker 2. And if we want to test scheduling another pod, test 2 for example, and let's do get pod again. As you see, test 2 was scheduled on worker 1, so the load was basically divided between the 2 worker nodes. Each one is running a test pod, and the IP address of the pod itself, as you see, is also from the CIDR block that we defined for WeaveNet. And as you see, worker 2 actually got its own subset of the CIDR block from the total IP range. Since, as I explained, the network plugin will evenly distribute its IP address range among the available worker nodes, giving each one its own CIDR block subset.